So one of the things that we can do is we can use either dot notation or we can use bracket notation when we want to get a handle to some value that's in an object. And so here on the left-hand side, you can see that I'm declaring an employee. And this employee is being an object. It has an empno key and a value of 7839. If I want to get access to that value or use that value in my application in some way, shape, or form, I can either use dot notation and reference the value, or I can use bracket notation. I can pass in the key as a string literal. So notice that these two values are exactly the same, and they will return the same value. The question then becomes, why in the world would I use one over the other? And it really just comes down to how exactly you are going to be referencing a property. And for example, if you know at runtime, or sorry, at build time, compile time, as you're writing the code, which property you want, dot notation works extremely well. I know in this case, I want to use a number. But if you know what the property is until the application is active running, maybe it depends on some user input. The user picks something, in which case you're going to return a different property. In that case, bracket notation becomes very helpful. And the reason for that is because rather than passing in a string literal like this, you could pass in a variable that's maybe being set by something. So imagine if you had a user interface that had different properties that you might want to read. The user is going to say, well, I want the employee number property. Oh, actually, no, I want the e-name property. No, actually, rather, I'd prefer the salary property. Well, we can use bracket notation to be able to pull any property that we need off of our object and do whatever we need with that property. So let's look at some examples. Real quick, while I talk about my examples here, I'm using an editor called Visual Studio Code. You can get it at code.visualstudio.com. And the other thing that you'll see me use to some degree while we're in this training is I'm using an extension that I really enjoy called Quokka. And I'll just show you that for a moment here. If I come over here to extensions and I look for Quokka, this is really tiny, but Quokka, Quokka. And this is a nice way to run code on your local machine without having necessarily put it on a site somewhere. It doesn't work perfectly in all scenarios. I think if you get the Pro version, it does some other stuff, but I've never used the Pro version, so I'm not too sure, but I imagine it helps make things a little easier. Okay, let's get back to our objects. Let me go ahead and close some of these panels. We have a little more viewing space. Perfect. Make this a little bit bigger. Okay, so let's go ahead and look at this first example here. Got a couple things that I want to pick apart. We have an object that we are declaring called king, and I'm kind of using the emp table employee data because it's a data set I think most of us should be kind of familiar with. I have an employee number property, 7839. I have a salary property of 5,000. And then I have a very weird property here that we're going to talk about in just a bit. The property that I want to focus on at the moment is equals. And why do I want to focus on that? Well, I want to focus on that because I am providing some functionality, a custom way for me to determine if king equals another employee. And in this case, the way that I decided to define equality, whether it's right or not, is that if the employee that is passed in has an employee number that is exactly the same as King's employee number, then I'm going to assume that they are the same employee. That may or may not be true. but that's how I defined it here. The other thing that I want to mention when it comes to defining objects is there's this very interesting component here. I want to point out, notice that there's 2 brackets. This is using that bracket notation that I talked about just a second ago. So to clarify, we're using this bracket notation. And we're accessing this king object. But what property or key are we accessing? Well, this is a very special property. And it's the property is called, well, toPrimitive. And the way that toPrimitive works is that it receives a hint. Which primitive are we looking for? And it really has 3 values, I believe. It can either be a string. So if we're trying to get the primitive string value of this object, how do we do that? And then if we're trying to get the number value, how do we do that? So what we've decided, or what I've written here, is I've said, okay, if the hint that is provided, if the value that we're looking for is a string, then I'm going to return empno is, and I'm going to return the employee number kind of as a string. If we're not looking for a string, in other words, we want to get like an actual number, then what we're going to do is we're going to go ahead and return the salary. And so this basically allows some primitive manipulation of our object, such as being able to increment or decrement our object. So if we attempt to have object and say plus equals some value, it's actually going to return the salary. Very cool. Okay, so let's take a look and see what happens. I could run this here, but actually I'm going to go ahead and just run this in a page. And let's look at what happens. And let's actually go ahead and we'll just start here. And I want to point out a couple different things. I'm defining king. I'm now taking my king object and I'm going to say plus 100. And then I'm just going to go ahead and alert my king value. And notice that it is going to yield employee number is 7839. It's not going to be some cryptic object information. Check this out. Go ahead and paste this down here. Actually, I'll make this a little bit bigger for us. I like to be able to see what's going on. I think that's helpful. Okay, defining my object and then doing a couple alerts. Let's see what happens. Okay. So we can see that my salary is 5,000 and the code that I ran said king plus 100, 5,000 plus 100, 5,100. Interesting. And then the other thing that I did is I just wanted to alert the king object. And what's cool about this is that it is returning this string here that I built. So I said empno is 7839. Notice how it doesn't return a kind of, it doesn't try to kind of turn the whole object into one massive string. It does exactly what I want. So I think that's a pretty awesome way of trying to configure how you interact with your object as a primitive. The other thing that I want to point out is that, let me go ahead and say okay, is that I have an object here. I have the usurper, and he's after the king. And I just want to point out that the values here are exactly the same. Employee number, 7839. Salary, 5,000. 7839. Salary, 5,000. They're exactly the same. So what happens if I try to alert their equality? And then what happens if I run this through my equals procedure or function? Let's go ahead and run this. Okay, notice that if I try to test equality for king to my usurper, we see that it's false, even though they have exactly the same values. There is no difference in that regard. Well, what about my equals function? I can see that it returns true. Why does it return true? Well, it returns true because I defined, or I created my own set of rules of what it means for these two objects to be equals, and that can be whatever I want. I could even just always return true and just say they're always equal, but that maybe wouldn't be a very good idea, but you could. Oh, and also just as a reminder, if you want to get this console open, the easiest way to do that is to go ahead and press F12, and that'll open up this console. So if you want to kind of run some code along with me, you can. And if you select the little console tab, that's how I got here. Okay. So as I just mentioned, objects are always passed by reference, not passed by value. And so objects do not, two objects, even with the exact same values, cannot equal each other. We have to write some custom logic to make that happen. Those of you kind of looking at this, you're probably thinking that there's a lot of similarities between defining king and then defining this usurper here. They have the same properties and they have similar values. Is there a way that we can start to normalize how exactly we go about creating objects that are supposed to have very similar properties and functionality? Well, it turns out we can. And if I go to my next slide here, I can define a function. I'll call it employee. It's the type of object that I'm looking for. And actually, there's a little bit of a typo that probably should be, or that really should be a capital E, so I can make it abundantly clear to the rest of the world that this is meant to be treated kind of as its own standalone object. So a little bit of an issue there in that code. But that being said, I can feed my employee function an employee number, and I can feed it a salary, and this will go ahead and it will map employee number and salary to this object. And a very easy way for me to make king and also the usurper is just to call new employee. Again, this should be a capital E because these are meant to be treated kind of very similar to a class. Let's look at an example here. So one thing that I want to point out that might not be obvious is I'll go ahead and just say let this equals. Now this can't sit here like this. I just want to just show something. The reason I'm able to say this dot and start assigning values is because there's this implicit object that gets created at the very beginning when I create this function. And so this just lets me refer to like the context to the object that is being created. Even though I didn't explicitly say this equals empty object, just note that that is implicitly happening. I don't have to write that code, and that's how I'm able to start assigning properties to this. And if I wanted to add my toPrimitive functionality, I can. Notice that I'm using the bracket notation in order to access this key. And you also, I guess, might be wondering, why am I using it this way? Well, notice that this key itself has its own dot in it. So what I can't do is I can't say this dot symbol dot toPrimitive. That just won't work. But what I can do is I can pass in this dot or symbol dot toPrimitive kind of as a reference to a key, and that works just fine. Just very briefly on symbols, you can kind of think of a symbol as a unique value, kind of like a global primary key, right? Its value can't really be reproduced. And so it's a very effective way at kind of hiding functionality on an object. And that's all I'm really going to get to on that. But note that if you want to explore more about symbols, I think they are a very interesting object that you can use in JavaScript. And then if I want to find my equals function that I had before, you can just say, see, I'm saying this dot equals, and then I'm going ahead and assigning it my function. And that way, now when I go ahead and define my king and my usurper, I can go ahead and just invoke the new keyword, pass in my employees, and now I have new objects that I can reference. Not bad. So in standalone scenarios, I think it's awesome to be able to use objects kind of as essentially as classes to be able to create instances of some data. Fantastic. So the thing that I want to cover, which I think really starts to directly tie to the code that we write in our Apex applications,